In this video, we'll look at calculating combinations and permutations in the graphing calculator. So for this example, from a group of 8 people, a president, vice president, and secretary are to be selected. In how many ways can this be done? Now, in this problem, notice that we're selecting 3 specific positions. We're not just choosing a group of 3 people. We're choosing 3 people for very specific positions. So being selected as president is very different than being selected as vice president, and that's very different than being selected as secretary. So to calculate this, let's think first how to do it mathematically, which will actually be pretty easy. So if we're going to select a president first, we have 8 people to choose from. If we're then going to choose a vice president, since we've already chosen one person out of the group, we would then have 7 people left to choose from. After we've chosen the vice president, we can then select a secretary, and there would be 6 people left to choose the secretary from. And we could just multiply these together, and what we would get is 336. And that's the basis of what a permutation is. So we have a permutation function in our calculator, and so what we'll put into that function is P8, 3. And so what we're looking for there, the first number is the number of things we have to select from, and then the second number is the number we're going to select. So the general form for permutation is P in R, where N is the number of things we have to select from, and R is the number of things we're going to select. So at most, N and R should be the same size, but otherwise R should always be a smaller number than N. So in our calculator, the way that we're going to type this in is we'll first type in the number, we'll select the permutation function in PR, and then we'll say how many items we want to select, and that's going to be 3. So on our calculator, we'll press 8. We'll go to the Math button, and then we want to go over to Probability. So over a couple to Probability, and we'll go down one to NPR for permutation. So we want to do 8 NPR3, and that's going to tell us the number of ways in which we can select 3 objects from 8 objects. And so that's 336. And so as a part of that 336, there could be the same people that are vice president, president, and secretary, but all jumbled up. So let's say that the president's first initial was J, and the vice president's first initial was S, and the secretary's first initial was P. So that's one of those 336. But we could rearrange those. Let's say S is the president, J is the vice president, and P is the secretary. It's the same 3 people, but in a different order. They have different positions now, and so that's counted as an additional way in which this can be done because the positions are different. So now let's look at a very similar example where the positions aren't actually different from one another. So if 3 people are to be selected for a committee from a group of 8 people, how many different committees are possible? So notice in this example, the 3 people to be chosen don't have different positions. It's just a group of 3 people. So it doesn't matter if you're chosen first or if you're chosen last. All that matters is whether you're on the committee or not. So this one's a little bit different because from our earlier example, we saw that if we rearranged the 3 people, we had something different. In this case, it won't be that way. If we rearrange them, it's still the same 3 people on the committee. So for this one, this is what we call a combination. And so we'll write it C in R. And so in this example, again, N will be the number of items we have to choose from, and R will be the number we want to choose. So this is going to be very similar in the calculator. We'll do 8, and then NCR, and then 3. So we'll press 8, and then the math button, over to probability. Notice in CR, combination is right below in PR for permutation, and then 3. And so what we get is 56. And so the reason why we get a smaller number here is again because the order that we select people doesn't actually matter. So combinations will always be a fewer number than permutations for the same N and R.